All right. Hello, everyone. Today we will learn how to read on NMR spectrum, and we will cover the number of signals, position of signals, integration of signals, and spin-spin coupling. All right. So the first example we would do is ethanol. If we think about ethanol structure, it has a CH3, CH2, OH. Therefore, if we take a look at this proton NMR, we can see that there are three peaks. So this is going to be the first peak right here at 3H, which I can label. All right, so this is going to be the first signal. This is going to be the second signal, and then this is going to be the third signal. So this means that we have three signals in our compound. In our case, ethanol has three different signals because each hydrogen is bonded to a different carbon. So if we draw out the structure of ethanol, we have a CH3, like I mentioned, a CH2, and we have an alcohol group. And so then the three signals are coming from the three different hydrogens that are in our compound, which are bonded to something else, something different every time. So for example, if we take a look at the CH3 bond, it is bonded to the CH2. The CH2 is bonded to the CH3 and the OH, and the OH is bonded to the CH2. So each H group is bonded to something different. So that is why there is three signals. If we look at the integration, we can see that there is a 3H, which I will pick a different color for. There is a 3H, there's a 2H, and a 1H. So the 3H comes from these three hydrogens, which are the ones in purple. The 2H comes from the two hydrogens here, and the 1H comes from the one hydrogen here. And so 3H is an integration of three hydrogens, 2H is an integration of two hydrogens, and 1H is an integration of just one hydrogen. So if we take a look at these integrations and where they are positioned, we can see that the 1H and the 2H are further downfield, which is to your left, and then 3H is upfield, which is to your right. So this is going to be upfield. And then to your left is going to be downfield, which is what I will write here. I'll just put down for downfield. Okay, so what this means is that the CH3 does not give up electrons or as many as CH2 because it is closer to the oxygen. So because of that, CH2 has to give up electrons to the oxygen, and that is why it is downfield, whereas the CH3 is upfield, which means it is lower energy. Okay, so now I'm gonna clear all my drawings and I'm gonna pick a different color. So now if we read the ppm values, proton NMR goes from 1 to 12 ppm. In our case, we are going from 0 to 4, which is the same thing. But at each ppm, there is a functional group present. Ethanol in this case is around 1.3, which is for the CH3 bond, my bad. The 3H integration, which is the CH3 bond, is around 1.3 ppm, and the 1.3 is signifies usually a CH, like a CH3 bond in our case. The 2H lays around 3.6, which is right here, and as we can see, it has 4 signals, so it is going to be a quartet, and this usually represents a CH2, but I will explain why it is down here instead of over here, because CH2 is usually around 1.7. And then the 1H seems to be around 3.7 ppm. And this represents an alcohol based on the spectra given. So if we take a look at the spectrum, we can see that alcohol, clear on my drawings. So alcohol is around from 0 to like usually 2 to 5. In our case, we are around 3.7. So this can represent the one alcohol because, as I mentioned before, the OH only has an integration of 1, which will make sense here. So anyways, what I was saying, the reason why the CH3 and CH2 are such different spots is because usually CH3 is around 0.9 and CH2 is usually 1.2, but it can increase based on what it is bonded to. Due to that, it is going to be further up the chart and more over here. Therefore, this is going to give us the structure of ethanol, which I mentioned is a CH3, which I mentioned is a CH3, CH2, and an alcohol. So that is how we can interpret proton NMR based on this example. So now, if we move on to the next example, which is going to be identifying it on an ibuprofen or just an anti-inflammatory drug, we can see that in this example, ibuprofen contains 1, 2, 3, 4, 5, 6, 7, around 8 signals. And so starting with the peak to the very right, which is the one I will color in blue, it shows that it is around 0.9 ppm. So this one right here is around 0.9 ppm. Again, it is a CH3 bond, so it is gonna be 0.9. This one right here is gonna be around 1.5.7. And so in this case, what this could mean is that it could represent as CH2. CH2 around 1.7 or so. However, as we can see, our peaks are zoomed in. And so even though we have 2 peaks in the first 2 lines that we have drawn, it does not mean we have an integration of 2H. Rather, it is a doublet. In this case of the CH3 bond, we would have an integration of 3H because of the CH3. All right, so then again, this is the same case in here. This is a doublet, but it would have an integration of 2H. However, if we move on, this with all these peaks right here is a multiplet, can be another CH bond based on its placement, which is around like 1.8 ppm. This one right here, it is a doublet, and the doublet is going to mean around 2.3, which can represent based on our structure, which I will show right now here on the drawings. So if we go back and look at the chart, so this is around 2.3-ish. It's like a carbonyl compound. And if we take a look at the structure of ibuprofen, ibuprofen has a carbonyl compound. And so then, yeah, this one can be a carbonyl compound. Now, if we continue on with the labeling of our peaks, we can see that here around 4, it is near 3.7 ppm, which can indicate the alcohol group present. So 3.7 ppm. And then around these 2, usually benzene ring is present around 7.2-ish. This is representing an aromatic ring. So this one's present around 7 to like 7.2-ish. So it represents the aromatic ring. So in terms of looking at all our ppms, what this leaves us with is the structure of ibuprofen, which is the one I will draw right now. So it's going to be first methyl group right here. It's going to be another methyl group right here. It's going to be a CH2 right here. It's going to be the the aromatic ring that is present in our compound. And then it is going to be another methyl group with the alcohol right here. Now I will show you the methyl group is at because I just explained it without drawing it. So this is where the methyl group is at. And then this is going to be the carbonyl group that was present around 3.7. So this is going to be the structure of ibuprofen, and based on our ppms, this is how we read a proton NMR. So thank you for watching, and I hope that you were able to learn and understand proton NMR better.